Hey, my name is Caleb, and I am wanting to demonstrate how to paint the seed of life, as you can see right here, in a single equation, which you can see the equation over here. Um, so we'll start by just going to FuzzyGraph.com to have a nice new template. And so this is basically the circle equation that FuzzyGraph just loads with the circle equation. Um, but the first step is to basically we can rearrange this equation by moving the 2 to the other side. So um, minus 2 equals 0. You can see the equation didn't change. And let's make it a radius 1 circle initially. So so now the question is, how can we have more than one circle? And you can actually, well, actually, one other thing first about the circle equation. There's really minus 0, and there's really there's also the circle equation. You can change the center of the circle. So ultimately, to do the seed of life like this, we're going to want 7 circles, one in the middle and then one right above. You basically would go directly above, and where the circle intersects with the where the vertical line intersects with the circle, like right here, that's the center of this circle here. And we go down below minus 1, there's another circle there. And then basically you can then, here, let's just do it like that. Okay, so then there's 7 circles total. So we can move a circle over those. So if we change this x minus 1, for example, that's going to move the circle 1 to the right. If we do x minus 1 and y minus 1, that's going to move the circle up here as the center, right? So that's this is the core idea. The whole thing is just doing 7 circles and combining them in a mathematical way that's kind of interesting. Now, just a note, actually, I tested. Well, let's actually we'll prototype this in Desmos just to show what the 7 circles are. So x squared plus y squared equals 1. That's one of them. In Desmos, you can do separate equations, which currently I don't allow in FuzzyGraph, but we'll do it. We'll do something like that soon. So actually, there's a little more subtlety. Anyway, so now we go x squared plus y minus 1 squared equals 1. So that's basically moving a circle. Let's zoom in. It's moving up to 1 and doing a center there and drawing a circle there. Now we're going to move down 1. So we're going to do the circle equation is actually x minus center. So it's actually like x minus center x comma y minus center y. So anyway, this is going to be x squared plus y plus 1 squared equals 1. Right, and then you can see basically where these meet. You see 0.866 something comma negative 5. You know, it's every permutation of 0.866 and 0.5. That's where they meet at. So we want to draw 4 more circles at each of those locations. So now we're going to do x minus 0.866 squared plus y minus 0.5 squared equals 1. Right, to get that one. And then x plus 0.866 squared plus y minus 0.5 squared equals 1. We got that one. And then x minus 0.866 squared plus y plus 0.5 squared equals 1. And then the last one is x plus 0.866 squared plus y minus 0.5 squared equals 1. Whoops. Oh, this should be a plus. There we go. Okay, so this is how you can draw the seed of life. And you can see it's basically just 7 circle equations, very simple. But the question is, how can we actually combine all these into a single equation? And I had a friend of mine ask me, hey, can you do like the seed of life as a single equation? And my initial answer was, well, maybe once I roll out the multi-equation feature, but not until then. But after looking at it, I kind of was challenged to do it. And so basically what it is, what you do is you just multiply each of these equations. So like, let's go back to 0. No, that's not right. 1. Let's make this 0, this one 0. You can basically just multiply, so times multiply, and then this one will be at -1, and then I can just multiply again. This one will be at +1. And then I'm going to do the x minus 0.866. Let's make this equation larger so we can see what's going on. 0.866, and then y should be 0.5 there. Move it up. And this will be, in this case, a plus. There's a surprising thing coming up. And one thing I want you to actually go ahead and notice here is you'll see, so some, like these lines here are getting really thin. And the center is getting really kind of fuzzy. And you can see this. Oh, look way out here. The error is like 2 million, 2.6 million, 4 million. Really high error out here. And basically the thing is, there's a subtlety here that the color is basically mapping into basically mapping different value ranges to different colors. Okay. Let's do the last 2 circles here. So this will be plus 0.5. And then the last one here, this should be plus 0.5, and that should be, I think it's plus 0.866. There. Let's let that load. It's kind of slow. I need to get a loading indicator for FuzzyGraph. All right, so there's the seed of life as a single equation. But it's obviously kind of, you can see the thing is the error when you have this error because basically at every point in this whole graph the error, basically you've got all these numbers and the error is just adding up for all these circle values and multiplying basically. So if the error in circle 1 is 5, the error in circle 2 is 10, that'd be 50 total. But it's 7 circles. So if you got, anyway, so the error increases, and that's why you're getting some of this washing out here. And we could increase the fuzzy level some, but let me show you what happens. So we got those lines are a little thicker. Let's go up a little bit more in the fuzzy level. Okay, now those lines are at least clear, but now the center is all washed out. And this is kind of something I've encountered in doing math art from time to time. Um, Now, if you look again, the error around zero is zero. There's no zero error here in the middle. But you come out here, and man, these numbers are huge. And so when you got such a large range, it's almost like the same kind of effect that can happen like if you're taking a photograph and you have like a really bright light source like the sun. It washes everything else out because your camera has to select different values, and there's such a strong contrast that by comparison to the sun, say maybe everything else looks black, right? And it's like this is like so bright that it's kind of just everything's merging. So the question is, can we make this a little more smooth? And there's a mathematical trick to smooth things out, which is just doing a square root. And doing a square root is the same as doing to the power of 1 over 2. And just watch what happens. I didn't put the whole thing in parentheses. Let's add the parentheses. And so you get something like this. And so you can see kind of some of this fuzziness around the edges. But it's still a little too washed out in the middle. So let's turn down the fuzz now, to use a technical term. And there we go. And this is just, now you see, like, it's just kind of interesting that you still have some of this glow, like you got this glow especially on the inner part. But it's just kind of interesting and surprising that it's like this perfectly clean line, and it's like that's just because of the color mapping. It happens that the color inside the circles, the error right here, for example, is like 5.7, but out here it's way higher. So 25 versus 7 versus, like, if you go in here, the error is like near 0, right? And in these areas here, the errors, why are these areas kind of like darker, right, compared to right here? Well, it's because there's more error here. Because I guess these circles it's almost like a wave interference pattern where they're like interfering. And in cases like this, you have destructive interference, and over here you have constructive interference. Same thing in here. And, we could even do like, let's do a different color map. And maybe we'll turn, ooh, wait, let's invert that. And we'll turn off the axes just so we can see a nice clean completed seed of life. And there you have it. Something kind of interesting. Somehow this thing is like, you notice the error when I drag here is like not updating when it's inside the circles, which is like, and out here, anywhere where it's dark, it updates quickly, but anywhere where it's light. This is kind of weird. I've never seen this happen on FuzzyGraph, so it's must be exhibiting some kind of buggy kind of behavior. Kind of surprising. Yeah, I honestly don't know what's going on there. Anyway, it's kind of cool. You have these circles. It's perfect. This nice clean look. I've actually painted almost this exact same, with like the negative space in here. But it's kind of cool to see that it's kind of got this glow in the center, because the center circle is kind of getting energy, so to speak, from all of the circles, so to speak. And so this here's the equation. So this equation here, and again, raising to the half power, that basically just smooths things out. I was curious if I could if I could do this single equation graphing in Desmos, and you can't really read it in here, but basically the answer is yes, you can. So this equation does work even outside of FuzzyGraph. But you can see, the difference between the two here versus here. You just have different things being shown, and there again, there's different data being shown. The error here is lower. Anyway, so there you have it. I'm not going to keep rambling. Sorry about that. So this is the seed of life in a single equation on FuzzyGraph, and FuzzyGraph is the world's first non-binary graphing calculator, meaning it can show the shades of error and not just where the equation is true or false, like over here. So thanks a lot. Have a good one.